All right, pre-cal 11, here we go. Section 3.2, we are talking multiplying and dividing rational expressions. If you're still unsure what a rational expression is, go back, watch lesson 3.1. And if you want to understand better how to graph rational expressions, go back to section 2.3. But today our focus is going to be placed on multiplying and dividing rational expressions. So what you'll notice is that multiplying and dividing rational expressions is exactly the same procedure that we did in grade 9 with multiplying and dividing fractions. The only difference now is we'll have unknowns in the numerator and denominator. The basic principles, though, are all going to be the same. We're going to look to cancel out common factors, numerator and denominator, when we're multiplying. So let's look at example 1. We have 3 over 10 times 5 over 9. Now, you'll recall if you had me in grade 9, when I originally introduced this to you, I talked about breaking everything down into a product of primes. So 10 is 2 times 5, and 9 is 3 times 3. The reason why we do this is so we can identify common factors that'll cancel out. 3 on top, 3 on the bottom, divide out to 1. 5 on top, 5 on the bottom, divide out to 1. So what we're left with on the top, those become 1s. And those become 1s. We don't write them in because at this point it should be intuitive. So the numerator is a 1 and the denominator is 2 times 3, 6. That should be rather straightforward. So now let's look at something a little more different, example 2. So what we have now is we have unknowns. We have x minus y over 2 times x, and we have x squared, which is x times x, over x minus y times x minus y. Now, it might simplify your life a little bit to do this. Now you can see you have common factors, right? What do we have? We have an x minus y on the top and on the bottom, and we have an x on the top and an x on the bottom. And it just comes down to what's left. In the numerator, all that's left is an x. In the denominator, all that's left is 2 times x minus y. Or to the y's, we cannot cancel the x's here. They need to be common factors, and it's not a factor on the bottom, it's part of an expression. So we are done. Okay, now moving into example 3. A little bit more space on the bottom. So here we are multiplying some things together. If you're just going to multiply the top, top, bottom, bottom, you're going to make your life a lot more difficult than it needs to be. Let's look at those expressions and see if we can simplify them. So what do we have? We have x squared minus 25 over x squared minus 4 times 4x minus 8 over 3x minus 15. Now, I'm hoping that this jumps out at you. It is a difference of squares. Perfect square, perfect square, perfect square, perfect square. And these factor nicely to x plus the square root of 25, x minus the square root of 25. So on the bottom, we get x plus 2, x minus 2. Now, for the second half, we're just going to tidy this up. For the second half, we have 4x minus 8. Common factor, 4. And you're left with x minus 2. On the bottom, common factor, 3. And you're left with x minus 5. Now we're looking for cancel top, cancel bottom. So, x minus 5, x minus 5, x minus 2, x minus 2. What do we have left? Well, on the top, we have 4 times x plus 5, and on the bottom, 3 times x plus 2. Now, there's no need to water bomb in the 4 and the 3. We're not going to be able to cancel anything out because these are currently in factored form. And if we could factor something out, we would do it right now. So we are done. On to page 2. All right, so example 4. I'm going to do this one in a bit more detail than the rest. We're looking for factors. all of these things. Can we factor them? And we can. The top, what can you factor? You factor an x. So you end up with x times x minus 3. On the bottom, this goes back to grade 10. We're looking for two numbers that multiply to negative 4 and add to negative 3. So this x minus 4, x plus 1. Now the next one, we're looking for two numbers that multiply to 4 and add to negative 5. So x minus 1, x minus 4. And then we're looking for two numbers that multiply to negative 3 and add to negative 2. So x minus 3, x plus 1. Now we cancel. Boom, 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 boom. And we're done. So what are we left with for this question? X times x minus 1 over x plus 1 squared. Next one. Factor out an x. On the bottom, two numbers that multiply to negative 6 and add to negative 1, x minus 3, x plus 2. Two numbers that multiply to negative 2 and add to positive 1. And factor out an x, and we get 1 minus x. So, a few things going on here. This will cancel here, this will cancel here, this will cancel here. And what we're left with now is x minus 1 over 1 minus x. Now those look similar, and there's a little something we can do here. Take the bottom, factor out a negative 1. So we'll have x minus 1 over negative x minus 1. Now we can cancel. And what are we left with? Negative 1. Last one. We had x minus 7. Denominator is 1. We can factor an x out of here, and we're x minus 1. And two numbers that multiply to negative, or positive 7, add to negative 8. X minus 7, x minus 1. Well, what factors here? Or what cancels here, sorry? Boom, 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 boom. What are we left with? Just an x. So that's an example of what we're trying to do here. In grade 9 fractions, I would always say, simplify before you multiply. As in, break it into factors, cancel out common factors, and then multiply what's left. It makes your life way easier. The reason why that focus was done in grade 9 was because of this. Because here, this makes your life way easier. All right, so factor and then simplify. All right, so on to page 3. We got one more example left here for multiplication, and I'm just going to whip through it so you can watch it a few times if you want. Now, there's quite a bit going on here. This one, we got to use the AC method, or factor by grouping, or the box method, whatever you were taught. I'm going to use the AC method to factor. So you multiply the 6 with the 2, and you rewrite it as x squared plus xy minus 12y squared. And now you're looking for two numbers that multiply to negative 12 and add to 1. So we have x plus 4, x minus 3. But you're not done, because since you've multiplied by the a term, you now have to divide by the a term. Simplify those fractions. And then write the remaining denominator in front of the x. You can look at my grade 10 notes for factoring, or you can go back to section 2.2. So the bottom, I'm just going to move this to the side for a minute so I have a little bit of extra space to do the AC method for 4x squared. So we end up with x squared minus 8xy plus 12y squared. Oh, and side note, I missed a y and a y here. So now we're looking for x minus 2y, x minus 6y, And we're dividing by our a value, which was a 4. We're simplifying. So x minus 1/2 y and x minus 3 over 2y. Bring the denominator up, we end up with 2x minus 1y and 2x minus 3y. So we've simplified, just making a little space here, the top. So 3x plus 2y over get those back in there. So 3x plus 2y times 2x minus 1y over, sorry guys, 2x minus 1y, 2x minus 3y. Now what I'm going to do is I'm actually going to take this question down here to finish it up. So start again here. 3x plus 2y times 2x minus y over 2x minus y times 2x minus 3y. So that's just the first fraction. Now we have times x minus y and 3x plus 2y, and then times, we can factor here a 4. We're left with 2x minus 3y, and we can factor a 2, and we're left with y minus x. So let's look and see what can cancel. 3x plus 2y, 3x plus 2y, 2x minus y, 2x minus y, 2x minus 3y, 2x minus 3y. Now if we look at what we have left, we're going to have that same scenario we had earlier, where you have an x minus y, and then here you have a y minus x. Factor to negative, and this becomes negative 2x minus y. So we'll use that. Because that allows these to cancel. And then your answer is just 4 divided by negative 2. So that's a pretty involved question. So watch that a couple times if you have to. Now, division is not much different of expressions. Okay. The only thing with division of the expressions is that we do the same thing we did with fractions. Flip the second fraction before you multiply. So first fraction stays as is. Change to multiplication. Flip the second fraction. Now I'm going to erase this long arrow here so I have some room to work. And you'll see that all I have to do is factor the second fraction now. So remember, you cannot cancel when you divide. You have to change to multiplication before you're allowed to cancel. There we go, all factored out. What cancels? Not a lot. X plus 2, x plus 2. What are we left with? Well, we're left with x minus 2 squared over x plus 3, x minus 1. Now, don't multiply those back together. You've simplified it. Don't make it less simple. We've got a couple more examples and we are done. No, we're done. So what I'm going to do is I'm going to scroll through to page 25 here, or number 25 on page 9, and I'm going to do this question for you. So, AC method at the top. I'm going to give a bit of room on the bottom here, and I'm going to do that. So, 4a squared minus ab minus 5b squared becomes a squared minus ab minus 20b squared, which factors to a minus 5, a minus 5b, and a plus 4b, and then we divide by our a term and simplify. So a minus 5 over 4b and a plus b. And then we rewrite the denominator in front. So 4a minus 5b times a plus b. I'm going to change to multiplication, and I'm going to flip. And since this is 4a minus 8b over 1, it's going to become 1 over. On the bottom here, this is a factor by grouping question, so we're going to rearrange to get the x's together and the y's together. I haven't done anything except rearrange their order, and now I can factor a little bit here. So on the top, I still have 4a minus 5b times a plus b times 1 over, factor of 4 out, 4 times a minus 2b. Now, if you look at the ax, bx, but you look at what we have on top, you got an ab by itself. So it's not going to factor out an x and a y, but am I going to end up with an a and a b? And you will. You're going to have factor an x out, and you're going to have a plus b, factor a y out, and you're going to have a plus b. So that becomes your common denominator. So now you have 4a minus 5b times a plus b over a plus b times x plus y times 1 over 4a minus 2b. The ab's cancel, and then you're just left with what you have left. So it's going to be 4a minus 5b over 4 times x plus y times a minus 2b, a rather nasty finish. If you scroll to the answer key, you'll see there it is. Not the most pleasant answer, but there's no rules that say the answers need to be pleasant. Thanks for watching, you guys. Remember, you got your 3.2 section, you got your answer key, detailed answer key on my website, and you can rewatch this video as many times as you need to. Hope you guys are well and healthy. Have a good one. See you next lesson.